We're going to go over the laws of exponents in very little time for your very little attention span. Now, you should probably know a little bit about exponents before we get into the laws of exponents. So the first thing you should know is that we can't have any negative exponents. I'll teach you how to deal with negative exponents later. If you can calculate it, do it. Here's an example. So here I have a variable, but then I have 3 over 3. I know what 3 over 3 is. It's 1. So 1 times x is just x. My answer would just be x here. Now, the third rule is combine only like terms, which means y's go with y's and x's go with x's. You'll see what I mean by this later on. The first rule is when I'm multiplying with exponents straight across, they just add together. For example, when I take x to the 7th power and I multiply it times x to the 2nd power, that would ultimately be x to the 9th power. A common misconception is that you multiply these two numbers, 7 times 2. Do not do that. It is 7 plus 2, just like here. A plus b, 7 plus 2, x to the 9th power. It gets a little trickier when I try and divide by variables with exponents attached. Let me give you an example. So, let's try something like this. Now, I ask myself 2 questions whenever I solve a problem like this. I ask myself, which side has more and how many more? So, which side has more, the bottom or the top? The top has more, right? So, then I ask myself, how many more? I just take the difference between the top and the bottom. Will have to be positive no matter what. You cannot have any negative exponents. So the difference between 7 and 2 is 5, and it's on the top. So it will be on the top of the fraction. Just like this. Let's try the same thing, but a little different. I ask myself which side has more. Now the bottom has more. The bottom has 5 more. I think we've already established that. So it would end up being 1 over x to the 5th power. Let me demonstrate how to use the distributive property when dealing with exponents. What I'm going to do here is distribute this 2 hanging off the parentheses into every single variable or number, including 2 here. So what that looks like is 2 to the 2nd power, x to the 3rd power, but now you're distributing it in, so it would be times 2, opposed to as when you're multiplying straight across, you'd be adding. Now you are multiplying. Same thing goes here, y to the 2nd times the 2 that I distributed in, and now I can start and solve the problem. Now, try these 3 challenging problems using each of the rules that you just learned. The next rule is very, very complicated, so you need to follow each and every step. So, if I take something like 2 and I put it to the 0 power, that will be 1. If I take 3 to the 0 power, that will also be 1, and if I take 4 to the 0 power, that will be 1 as well. And if I take 396, that's also 1, and if I took 1,000,000 to the 0 power, that's also 1. So anything to the 0 power is 1. So the final rule is just simply restating that you cannot have any negative exponents. So what happens here is I take whatever side, either the top or the bottom of the fraction. If there's no fraction, I'll just put a 1 underneath. I take whatever side has the negative, and then I move it to the other side. That will then make the exponent positive. Remember, all we are trying to do is get rid of negative exponents. Let's try this one. You just simply move whatever side this entire thing is on, if its exponent is negative, and you move it to the other side. Try and pause the video and see if you can solve these beneficial practice problems by yourself.